Apart from the industrial and military applications, augmented reality is also popular because of video games which can be in two-dimensional or three-dimensional form. One such popular game is Fallout 4, a role-playing game where the game depicts a story set in a world after nuclear war. The players in the game wear an augmented reality device which keeps a check on the health of the player and provides a status of the stock of essentials like ammunition, water, energy levels, etc. These role-playing games where the audience contributes to the story are truly interactive, and this has added to their popularity. The player's experiential is what makes these RPG games popular. Doctors and surgeons can now treat their patients from different locations. Tourists can visit new places, see new museums and scenic places in a virtual manner with the help of augmented systems. Specialized augmented applications to ensure safety of the users are also being developed. These applications use a mobile phone to communicate the exact location coordinates of the user to the police or the medical representatives in case of an emergency. The safety application uses geolocation sensors and motion sensors to track the position and direction of the user. The augmented device can show a variety of information on the display, right from the game to scenery to a piece of furniture you are interested in. Augmented reality software supports and allows digital information like videos, images, hyperlinks, games and apps to be superimposed on the real world items in the form of a new layer. These AR systems are different from a smartphone which gives 2D information about the user's location and destination while traveling. Azuma has identified 3 characteristics that define augmented reality. First, it combines real and virtual. Second, it's interactive in real time. Third, it is registered in 3D. The level of interactivity can be simple like changing the perspective of the real world and complex like creating and interacting with the information. These interactions can be non-linear and depending on the complexity require special hardware. Let's imagine a case where the user wants to construct a new home on a vacant piece of land. Through AR, one can create a virtual house and see all its features, rooms as if the house is completed. One can open the door, color the doors and rooms differently, place props, etc. These are all possible with augmented reality. The real world consists of physical entities, buildings, infrastructure, natural landscapes and mountains. AR systems provide a place for representation of ideas which can be made interactive and don't require much physical space. Till the 20th century, to visualize some construction or a building, the only way was to make a model or a sample construction of that thing. If it was desired to make a piece of information available in a specific physical space, the only real way to do it was to create a physical artifact that either was or contained a representation of that piece of information. For example, if it was desired to indicate the maximum rate of speed at a certain place on a specific road, a physical sign would be erected that was constructed to convey the desired information. Let's look at the hardware and the gear used in AR. In AR, the user generally wears a special pair of glasses to experience the enhanced layer or interacts with the AR applications through his smartphone. Devices used in AR can be either wearable or non-wearable. Devices like helmets, contact lenses, wristwatches are wearable. Devices like mobiles, tablets, notebooks are non-wearable, that is, they can't be worn on the body but are portable. Augmented reality headsets can be see-through or closed view. Headsets help in giving directions to the user and also in visualization of objects. These headsets measure the health parameters of the person with the help of sensors. Parameters like oxygen level, glucose level and heart rate can also be measured. In augmented reality, computer-generated enhancements such as sound effects, computer-generated graphics and animation are used to enhance the experiential of the real-world environment. By using these components of multimedia like sound, video and graphics, an individual's present perception of reality can be easily altered. Moving on, let's look at seeing augmented reality. Augmented reality can be presented in three different ways. The first way, visual see-through method, was developed in 1960s by Sutherland, is one of the best ways to experience augmented reality. In this method, a see-through lens or a glass is used by the user to see the unmodified world, and then the system displays the digital information which is overlaid on the glass with the help of the transparent displays. Second method is the obstructed view. In this method, a head-mounted display is used which blocks the user's vision of the real world. The displays in HMD come from a camera which is placed at a front position in the head-mounted display. The augmented information in any format is blended with the feed given by the camera. The feed given by the camera can be in 2-dimension or 3-dimension depending on the number of cameras used and the way their feed is edited and combined. The third method is called the projected method. In this method, the augmented layer is projected from the headset on the real world, resulting in displays with digital information. For a better display, rendering is used in these optical projection systems and display systems. Augmented devices like glasses, helmets, HMDs use the following technologies. Firstly, it uses a GPU, a graphics processing unit, to ensure that the display and projection is smooth. Second, it uses display projection devices and optics to create and show the images in the user's field of view. Sensors. There are three types of sensors. First is the forward looking, to see the world the user is looking at a particular time. Sensor is also used to see the real world position in order to map the world in 3-dimension. Thirdly, motion sensors, to track the motion of the user in the environment. Three primary categories of sensors are used in AR systems: sensors for tracking, sensors for gathering environmental information, and sensors for gathering user input. Audio systems are also used, which includes microphones, audio processors and speakers to communicate and make the augmented application truly interactive. Object identification systems are used to identify the furniture or the objects glasses are looking at a particular time. It can be a table, a chair, windows, almirah, etc. This helps in placing virtual images and information on top of that. Accurate identification systems are a must for a flawless AR system. Some AR systems also use markers for this purpose. An operating system to control the virtual images is also used. Voice and hand movements can be used to interact with the images in this operating system. Some of the open source software to create applications and content management in AR are AR Toolkit, Argon and Goblin XNA. Let's look at the differences between virtual reality and augmented reality. These technologies offer different experiences to human beings. In virtual reality, the user experiences a completely isolated, computer-generated virtual world. while the augmented reality system gives the user additional visual information created digitally to experience both the virtual and the physical world at the same time. The user can enjoy experiential of both the real and virtual world with the help of a glass. The hardware used in graphics and to run the software tools are quite similar in AR and VR. Augmented reality has some additional requirements to take care of optics used in tracking and registration that makes it a more complex task. Augmented reality developer has to take the help of a motion sensor, orientation sensors and computer algorithms to program the movement of camera through automation. Since the AR user can also see real objects at the same time, tracking and positional information about the real and virtual objects has to be correct. Let's assume a real glass table with a virtual cat on it. The movement of the cat on the glass table changes its size with respect to the camera of the HMD. As one goes near to the table, the size of the table and the cat becomes bigger and matches the perspective in terms of scaling and position. This happens with the help of a smooth tracking, proper lighting and accurate image generation and real-time rendering. So one can imagine the role played by hardware which has to be fast and properly configured. Light field displays are used to match apparent focal lengths, which can be a problem when the user shifts his vision from a visual image which is at a distance to a physical real object which is quite close to the user. This problem also destabilizes the user and may give him a false illusion. Users are easily able to experience the AR system and tell if it's working for them or not. Their experiential helps in making AR systems better. Focal length differentiates augmented reality from virtual reality. Efficient AR systems dynamically adjust focal lengths for the convenience of the user, whereas in VR it is absent.